have the Palmer Penguins data set here, which I'm going to use to demonstrate how to construct a simple linear regression model using JASP. The first thing we want to do is construct a scatter plot to double check that our variables have a linear relationship. There's a separate video that shows you how to do this. Really quickly, I'll just go to regression correlation matrix. I'm going to be using the bill length and bill depth variables in this example. And if I select correlation matrix, we get a scatter plot here. We can see that the relationship between these two variables is relatively weak, but it's definitely a negative correlation and it's a linear relationship. So we can go ahead and construct our simple linear regression model using these two variables. To get the regression model, we'll go to regression, linear regression. Let's predict bill depth using bill length. So depth is the dependent variable and length is the independent variable. Once we select our two variables, JASP will give us three tables. In the first table, what you're probably most interested in is R squared. That's your coefficient of determination. The second table is an ANOVA source table. This is giving you information about the statistical significance of the overall model. Because this is a simple linear regression model, we only have one independent variable, so the ANOVA source table is going to be redundant with the coefficients table. The coefficients table is the one that you're most interested in. This is going to give us our y-intercept and our slope. When we're conducting a hypothesis test with simple linear regression, what we're usually interested in is testing the statistical significance of the slope, which uses this t-test statistic and this p-value. For this class, this is where your textbook stops. If you take a more advanced statistics course or research methods course, you may be asked to test some additional assumptions. In this class, we know that we need to have a linear relationship between the two variables. There are some additional assumptions, which you can check by going to plots. The first one I would select is residuals versus predicted. Some folks will call this residuals versus fits. When you look at this plot, you want to see essentially a correlation of 0. So there should be no relationship between the predicted values and the residuals. You also want to see that the variances are relatively equal across all predicted values. So you want to see a blob. You don't want to see a fan. You don't want to see a bow tie shape. You just want to see a blob of dots, which is what we have here. The last plot you may want to look at is a histogram of the residuals, preferably unstandardized. So for some reason in JASP, the default is standardized. I would uncheck that. The residuals should be approximately normally distributed. I like to check that assumption using the histogram. You could also check it using a QQ plot. If the residuals are normally distributed, they'll be on the red line here. As long as they're close to the red line, which they are in this case, we would say that the residuals are approximately normally distributed. Again, these last three plots that we looked at are things that you may be asked to do in a more advanced statistics course or research methods course. For this course, what you really need is the R squared value here and information from this coefficients table.